So we're going to take a look at amortizing a mortgage. Yesterday we kind of touched on a lot of definitions regarding mortgages and everything that kind of works with it. So again, I'm showing you a table and I'm also showing you a graph. And this table comes from the textbook. It's page 446, but more likely comes from a website. So if you're taking a look at this table, it's a mortgage over 15 years. It's actually the Babiaks, and they have a mortgage for $100,000 loan. So there's always interest when you get a mortgage, and over the 15 years, that interest accumulates, and you pay off your principal. So there is a mortgage calculator. There's more than one online that you can use, and later on I'll kind of show you what that looks like. But for now, I just want you to kind of look at this table and this graph, and it basically shows how the mortgage is repaid year by year over the 15 years. So I want you to kind of look at this and see if you see any patterns in the table or in the graph. And why do you think these patterns occur? And these are the same questions that we're going to answer throughout the lesson. So if you just want to kind of take a second and notice a few things, like I notice at the beginning with 0 years, you haven't started paying it yet. The mortgage is for $100,000, but at the end of the 15 years, which is the goal, is to have it paid off. You should be noticing some things with the total payments. Okay, there's a couple things to notice there. And again, we'll kind of evaluate that or analyze that, at the end. And same with the principal and the interest. So there's a couple things that happen in this table, and that's what we'll take a look at. So mortgage interest rates. Under Canadian law, interest on mortgages can be compounded at most semi-annually. So we'll just fill in that little part. So this is the law. Banks are not allowed to have any other compounding period for interest on mortgages other than semi-annually. However, mortgage payments are often made monthly. Now, we saw this yesterday. We were kind of toying the idea of different types of payments, so weekly, bi-weekly, accelerated weekly, and accelerated bi-weekly. We also looked at monthly. Most people do monthly, but that's not the only option, as we saw yesterday. These monthly payments form an annuity whose present value is the principal originally borrowed. So we used formulas for annuities and present value, so you know how to use those formulas. But since the payment period and compounding period are different, so the payment period is monthly and the compounding period is semi-annually, we can't calculate the monthly payment on a mortgage by using the formula. There's a couple typos in here. And so we can't use the formula for present value of an ordinary simple annuity. We have to use the TVM solver instead. So there's actually no way of doing this by hand. You have to use technology, whether it be an Excel spreadsheet or whether it be the TVM solver. I'll show you how to do that when we get there. But what's important is that you know that when you do use the TVM solver, that you're setting the payments per year at 12 and that you're setting the compounding periods per year at 12 as well. Yeah. That's not right. Sorry. The payments per year, since it's monthly, there's 12 monthly payments per year. But this one here, that's actually an error. The compounding period per year should be semi-annually, which represents just the number 2. So make sure that you fix that. That'll change your answer if you don't put the compounding period at 2. Okay, so the Confirmas take out a mortgage of $210,000 at 5% per year, compounded semi-annually for 25 years. That's pretty typical. A house can cost about $210,000. Now houses range pretty high for a decent sized house, but it depends what you're looking for. $210,000 is pretty reasonable. 5% interest, I'd say right now is pretty reasonable as well. On Friday, you guys are going to have a project where you'll be investigating interest rates for mortgages, so you'll get a better idea if this is reasonable or not. And 25 years for a mortgage, as we discussed before, is reasonable as well. So if we want to figure out the monthly payment, we can't use the formula, the one that we learned. So we are not allowed to use this one here. So you don't need to write it. I'm just writing it to show you that you should not be using this. okay? So do not use that formula, and that's because the compounding period and the payments are different. So what we can use is using the TVM solver. So just write this in so that you know which method to use. So you're going to use the TVM solver, and we're going to enter the known values. So hopefully you have a graphing calculator. If you don't, maybe someone can pause the video and you guys can all get a graphing calculator before starting this. But here's mine. And so when you go to the TVM solver, you just press Apps, Finance, number 1 for TVM solver. And we have to fill in these values. So remember that N is actually the number of payments. So you have to make sure, the number of payments. So in this case here, for the number of payments, your mortgage is out for 25 years. Gotta bring this up a bit. It's out for 25 years, and you're making payments monthly. So that means you have to multiply 25 by 12. So it gives you a total of 300 payments over the 25 years. The interest rate is given in percentage, so that's 5. And as you noticed, I did the multiplication right into the calculator, and it's very easy to do. It's actually easier to get out, to stay in the screen than to get out. And then I just press enter. The present value is your mortgage amount. So in this case, it's $210,000. You want to set the payment to 0 because you're looking for the payment. The final value is at the end of your mortgage, and the goal at the end of your mortgage is to have it paid off. There are 12 payments per year, but it is compounded semi-annually. So you noticed, I don't know if you did notice, but when I changed the 12, so this was a 4 originally, it changes the compounding period per year automatically, but you have to make sure that you change it back to a 2, okay? So when we go back up to payment, we just need to press alpha solve, and we get payments of $1,221.37. So again, our monthly payments are $1,221.37. So we can just answer the question. Therefore, the Kafirma's monthly payments are $1,221, and we'll round this to 37 cents. Okay, don't put the negative. The negative is just indicating that the money comes out of your account. So this is how much the Kafirmas pay on a monthly basis. Now, if we want to calculate the total interest paid over the 25 years, what you can do is, because you know that there are 300 payments, okay, and we discovered that earlier by taking the 25 years and multiplying it by 12, which gave us the 300. So since there are 300 payments per year, and we multiply that by the same payments that these people will be making for 25 years, you can evaluate what that gives you. So if we try that, to get out of this page, you just have to press second mode. Okay, so you go 300 payments times 1,221.37 cents. It gives you $366,411. So that is not the total interest. This is just the total amount that they pay for their house. Now you'll notice that the original price of the house was $210,000. Well, that's the price you pay when you take out a mortgage. You don't really recognize that you're paying that much interest that we're going to calculate in a second, but it's pretty high. So what we're going to do is, because we know the house, the principal on the house is $210,000, to find the total interest, we have to take the $366,411 and subtract from the original price of the house to see how much more they paid. So if we check that out, 366,411 minus 210,000. So they end up paying $156,411 extra dollars in interest, which is pretty intense. Again, you don't really notice that you're paying $156,000 more on your house over the 25 years because the payments are manageable. But when you look at it this way, it's a lot more money in interest. So we're just going to answer the question here. Therefore, the total interest is $156,411. So that's extra money that they pay for the house. There's another way of doing this. You can use a graphing calculator. So to use the graphing calculator, it's fairly easy. You just have to remember the function. So what you do is once you've typed into your TVM solver, I'm just going to go back to the TVM solver. So I pressed apps, enter. Once you know that the payments are $1,221.37, you can actually press apps again, finance again, but this time, don't be so quick to press number 1. If you scroll down, there's a couple of different options. And option A is the sum of the interest. So that's where you can calculate the interest on your payment. Now, when you're typing this in, I'm not sure if it's going to work up here, but I'll give it a try and see what happens. There's 2 things that you need to type in. The first value needs to be the first payment. So you need to type in 1. And then the second value needs to be the second payment or the total amount of payments. So it depends what you're doing. In this case here, the second payment is the final payment because we want to find out how much interest it is over the full 25 years. So I'm going to put in 300 here and press enter. Not sure if this is going to work. Yep, it worked in this spot as well. So we get the same answer, $156,411. This one has a couple different cents, and that's just because the calculator is a bit more specific. But this is a way to calculate the interest. So I just have this little box here at the end of the note. I didn't put it on your note, but just take a look at what the interest button actually does. So the important part here is just to know that the first number will usually be a 1, and 1 represents the starting payment. And in our case, it was 300. It represented the last payment. In this example that I found, the last payment was actually after 5 years. So that's why their number was 60. But our number was 300 because 300 was the amount of payments that we were making. They add an extra 2. You can do that. The 2 just represents the decimal values, but I find it changes your answer a little bit. Not by much, but the calculator does round a little bit differently as well. So that's at the bottom of the note if you want to review the video or write it down after. So a mortgage is amortized. So that's a new word. Mortgage is amortized. When both the principal and the interest are paid off with a series of equal regular payments. It has to be equal and regular payments. So for example, the mortgage in example 1 was amortized by making monthly payments of $1,221.37 over an amortization period of 25 years. So a mortgage is usually amortized because people don't typically have $210,000 just in their back pocket. So they have to take out a loan. And when you take out a loan, that's your mortgage. Now, to simplify the math, we're assuming that the interest rate is fixed for the entire amortization period. But really, in real life, mortgage interest rates are fixed for shorter length of time. That should be time, not line. Okay, so shorter length of time. And that is actually what we call the term of the mortgage. So I don't know if you've heard your parents say, oh, we need to renew our mortgage. It's been 5 years. A lot of people have a 5-year term for their mortgages. And then what happens is that at the end of the term, the mortgage has to be paid off and or renewed at the current rate of interest. So interest rates are ever changing. And so you only get your interest rate for about 5 years. You can choose to have a different term, but sometimes there's disadvantages to that as well. The term normally ranges from 6 months to 10 years. So We can use an amortization table to analyze how a mortgage is repaid. The amortization table gives a detailed breakdown of the interest and the principal paid by each payment and the loan balance after the payment. So these tables you can find online. I found